Hello future doctors, engineers. Welcome to Chintasaala. Today, we're kicking off one of the most fundamental chapters in physics, units and measurements. This chapter is the backbone of all problem solving in physics, whether it's your grade 11 exams, NEET, or even GE and other engineering entrances. In this lesson, we'll break down the International System of Units, SI, the language scientists speak worldwide, the art of significant figures and error handling, because a small mistake in decimal can cost a big disaster, and how dimensional analysis can be your secret shortcut weapon in exams. By the end of this session, you'll not only master the theory but also learn the smart strategies to crack MCQs in NEET, GE, and board exams with confidence. So, grab your notebook, switch on your scientific brain, and let's start building the foundation of physics, one unit, one measurement at a time. Don't forget, this is just the beginning. The concepts you learn here will echo throughout your physics journey, and their manifestation in the physical world. Measurement is fundamental to physics because it allows us to quantify observations and compare results. Every physical phenomenon can be described in terms of measurable quantities. In our exploration of physics, we find it's the study of the laws of nature and their manifestations in the physical world. Measurement is at the heart of physics, allowing us to quantify observations and compare results. What are physical quantities? Physical quantities are properties of objects or phenomena that can be measured and expressed numerically. Examples: length, mass, time, temperature, electric current, luminous intensity, amount of substance. Physical quantities are classified into two types. Fundamental quantities. These are basic quantities that are independent and cannot be expressed in terms of other physical quantities. There are 7 fundamental quantities in the SI system: length, mass, time, electric current, temperature, amount of substance, luminous intensity. Next, derived quantities. These are quantities that are derived from fundamental quantities through mathematical relationships. Examples: area, derived from length times length, m squared, speed, derived from length, time, meter per second, density, derived from mass, volume, kilogram per cubic meter. Force, derived from mass times acceleration, kilogram meter per square second. Importance of measurement in physics. Measurement provides a standard way to describe and compare physical quantities. Accurate measurement is essential for scientific experiments, engineering, and daily life. Without measurement, scientific laws and theories cannot be tested or validated. Need for standard unit. To avoid confusion and ensure consistency, standard units are used worldwide. A standard unit is a fixed quantity used as a basis for measuring physical quantities. Example: the meter is the standard unit of length. Key points to remember: every measurement consists of a number, magnitude, and a unit, e.g., 5 meters. Hence we conclude, physical quantities are measurable properties of matter or phenomena. They are classified as fundamental or derived quantities. Measurement and standard units are essential for scientific communication and progress. Units of measurement. A unit is a standard quantity used to express a physical quantity. System of units: CGS system, centimeter, gram, second; FPS system, foot, pound, second; MKS system, meter, kilogram, second; SI system, International System of Units, the most widely used system. It has 7 base units: meter, kilogram, second, ampere, Kelvin, mole, candela. What is a unit? A unit is a standard quantity used to specify measurements of physical quantities. Every measurement is expressed as the product of a number and a unit. Example: 5 meters, 5 is the number, meter is the unit. Characteristics of a good unit. A good unit should have the following properties: well defined, its value should be clear and unambiguous. Accessible, it should be easy to reproduce anywhere. Invariable, it should not change with time, place, or physical conditions. Convenient size, neither too large nor too small for practical use. Types of units: for fundamental units, meter for length, kilogram for mass. For derived units, meter per second for speed, Newton for force. Systems of unit. Over time, different systems of units have been used. The main systems are CGS system, based on centimeter, length, gram, mass, second, time, used mainly in older scientific literature. FPS system, based on foot, length, pound, mass, second, time, used in some English-speaking countries. MKS system, based on meter, length, kilogram, mass, second, time, predecessor to the SI system. SI system, the most widely used and internationally accepted system. Established in 1960 by the General Conference on Weights and Measures. Consists of 7 base units, see next section. These units are used as the foundation for all other measurements in science and engineering. Supplementary SI units, now considered derived units. Radian, rad, unit of plane angle. Steradian, senior, unit of solid angle. Advantages of the SI system: universal acceptance, used worldwide, making scientific communication easier. Decimal system, based on powers of 10, simplifying calculations and conversions. Coherence, derived units are directly related to base units without conversion factors. Derived SI units: area, square meter, m squared, volume, cubic meter, m cubed, speed, meter per second, force, Newton, N, equals kilogram meter per square second. Pressure, Pascal, par, equals N per square meter. Energy, Joule, J, equals Nm. Practical units and prefixes. SI units use prefixes to represent multiples or submultiples. Common prefixes: kilo, K, 10 to the power of 3, 1 kilometer equals 1000 meters, centi, c, 10 squared, 1 centimeter equals 0.01 meter, milli, m, 10 cubed, 1 millimeter equals 0.001 meter, micro, mu, 10 to the power of 6, 1 micrometer equals 0.00001 meter. Conversion between units: to convert from one unit to another, multiply or divide by the appropriate power of 10. Example: 1 kilometer equals 1000 meters. 1 meter equals 100 centimeters. Hence we conclude, units are essential for expressing and comparing measurements. The SI system is the standard system of units used worldwide. Understanding units and their conversions is fundamental for all scientific work.